Hello everyone, my name is Rohit Patil and my teammates are Alfattahkhan, Rutuja and Mansi. We are group number 38 from DY Patil College of Engineering and Technology, Kasba Bauda, Kolhapur, presenting on our project topic X-ray based arm fracture analysis and MRI necessity prediction using machine learning under the guidance of Professor S.S. Kore sir. So, to introduce with our topic, bone fractures are common medical conditions that require timely and accurate detection so that the patient can be treated effectively. Traditional diagnosis methods rely on manual analysis of X ray images by radiologists. Considering the increasing number of patients day by day, this process can be time consuming and error prone. So, we have developed a system which uses advanced machine learning and computer vision techniques to automate the fracture detection process. This automated approach ensures faster, more reliable, and consistent classification of fractures from the X ray images. Now, my teammate Rutuja will continue with the literature survey.
Hello, this is Rutuja and I'm presenting literature survey. So the prior research focusing on identifying bone fractures using X-ray images from trusted databases like TCIA and IIEST. The dataset initially had only 100 images, so data augmentation was used to expand it. And techniques like tiny edge detection and GLCM were applied to detect bone edges. Machine learning models such as Navi-based, decision trees, random forest, and SVM were tested, and SVM achieved 88% accuracy also. Deep learning models like ResNet 101, Inception ResNet V2 were also used, with Inception ResNet V2 achieving the best results with 94.58% precision. However, EfficientNet B0 known for its lightweight architecture and high accuracy, and it is more optimal choice for real-time, mobile or resource-limited environments. Next slide is the need of work. So the bone fractures are becoming more complex and harder to diagnose manually. And we know we need faster, smarter and automated diagnostic tools. So relying on doctors to read x-rays manually isn't scalable, especially in rural or undeserved areas. An AI-based system using models like EfficientNet B0 can accurately detect fractures and reduce human error and support overwork of doctors. Next is a problem statement. Doctors often face challenges in detecting arm bone fractures through x-rays because fractures can be subtle, x-ray image quality can vary, and manual diagnosis can lead to misdiagnosis or missed fractures. Additionally, there is no standardized way to decide when an MRI is necessary, which can delay treatment, increases patient cost, and may lead to inconsistent care. So, this project proposes a machine learning system that automatically detects fractures from X-ray images and gives smart and consistent MRI recommendation based on image analysis. This helps improve accuracy, reduces doctors' workload, and ensures better patient outcomes. Next point will be explained by my teammate Mansi.
My name is Mansi Shivade. The primary objective of our project are first, to automate the detection of arm bone fracture from X-ray images using machine learning. In this, we are used a algorithm to analyze medical images and identify possible fractures without manual intervention. Second, we aim to reduce variability and human errors in fracture diagnosis, since doctor may interpret X-rays differently based on experience. So our system provides a standardized analysis, improving overall diagnostic consistency and accuracy. Third, we want to standardize MRI recommendations through data-driven analysis. So our model will decide whether there is a really need of MRI or not and helping avoid unnecessary scans. And finally, the ultimate goal is to enhance diagnostic accuracy and improve patient care outcomes. So by delivering precise fracture detection and MRI recommendation, we ensure timely and effective treatment. So let me explain the system architecture of our project. So starting with the user interface, this is where the user begins interacting with the system. The main task here is to upload an X-ray image of the arm. Data collections. Once the image is uploaded, it is stored securely. So this step ensures that the data is well organized and easily accessible for further processing and model training. Image preprocessing. Before the image is analyzed, it undergoes pre-processing to enhance quality and remove noise. This includes techniques such as normalization, resizing, and converting the image to grayscale, making it suitable for analysis by the machine learning model. Feature extraction using CNN. At this stage, we use the algorithm EfficientNet B0 to extract features from the image. Low-level features like edges and textures are first detected, then high-level features such as a bone fracture shapes are identified. Feature selection. Once features are extracted, we filter out the irrelevant ones. This helps focus on the most critical data needed for accurate fracture detection, reducing unnecessary computation and improving efficiency. Model training. Using the selected features, we train our machine learning model. This model learns to detect fractures and predict whether an MRI is needed. Bone fracture detection. After training the model, system is able to analyze new X-ray images and detect the presence of fractures with high reliability. MRI necessity recommendation. Finally, based on the fracture analysis, the system decides if an MRI is necessary. If yes, it recommends the patient undergo an MRI for deeper investigation. If no, it concludes that additional imaging is not required. My teammate will continue with the modules of our project.
Hello everyone, I'm Alfattahkhan and I will be explaining the key modules and the user interface of our bone fracture detection system. Our system is divided into three main modules. Module 1 is the data pre-processing and augmentation. This model collect and prepare the X-ray images. It clean, resize and enhance them so the model can learn better during training. Model 2 is a fracture detection. This model uses machine learning to analyze the X-ray and automatically detect if there are fracture in the arm bone. Module 3 is the evaluation and validation. It checks the model's accuracy using precision, recall and F1 score to make sure the system performs well in a different cases. Now moving on the user interface, the user start by uploading an X-ray image. Then by clicking the scan button, the model process the image and show the result. It tells whether fracture is detected or not and also suggests symptoms and basic remedies. The interface is kept simple and easy for anyone to use. That's all from my side. Now I will hand it over to Rohit, who will continue with the next part.
As we have seen the modules implemented, now let us check what is the scope of future work on this project. We can develop an AI-based system to predict if MRI is necessary or not based on the X-ray image analysis. Also, dataset can be increased to train the machine learning model so we can get more accurate results for the X-ray analysis. Coming to the conclusion of this project, the machine learning system that we have developed aims to enhance the orthopedic diagnostics by automating the bone fracture detection process. This project also holds the potential to improve the diagnostic accuracy, reduce errors, and optimize the healthcare resources. By integrating AI into this diagnostic process, it can contribute to by integrating artificial intelligence into this diagnostic process, it can contribute to better patient outcomes and advance the application of AI in medical imaging. Thank you.
Welcome to our project demo, an AI-based system for arm bone fracture detection and MRI recommendation. Users can start by registering or logging into the platform. Once logged in, they can upload an X-ray image through a simple interface. The image is processed using a machine learning model, here EfficientNet B0, which classifies the case as either fractured or non-fractured. If a fracture is detected and appears complex, the system smartly suggests an MRI for further evaluation. This tool reduces the chances of human error, speeds up the diagnosis, and assists doctors in making quicker and more accurate decisions. Thank you for watching.